All right, number 13. We want to find the antiderivative of CSC cosecant squared theta plus 9 with respect to theta. Since there's no power being raised, I can write these as two separate integrals, antiderivatives. Okay, so I should put a d theta here as well. All right, so usually when I'm doing the trig functions, instead of trying to do this power rule, let's always double check to see if there's already a given antiderivative. We can do it with algebraic functions, just add a theta. But cosecant squared, I'm going to go to our cheat sheet with derivatives and common integrals and see if we have a cosecant squared antiderivative already given. So first we have a few rules, and then we get to the trig and transcendental functions. Got E, got cosine, secant, tangent, tan. Got secant squared, secant. Okay, so we have cosecant squared. The derivative of cosecant squared is going to be equal to a negative cotangent. So this antiderivative of cosecant squared is negative cotangent, and then you can see a plus c, and then the antiderivative of 9 with our algebraic function would just be 9 theta. So based on the given, this will be a negative cotangent of theta plus 9 times theta plus c. So this will be our antiderivative integral for number 13. Cotangent of theta plus 9 theta plus c. All right, 14, we want to find the integral of this function. Integral, I'm just going to put a 1 up here. I'm going to write it and put this dx out to the back. This is x square root 169 x squared minus 169. Now, to me, just offhand, it looks like something will factor, and this looks like one of those special antiderivative functions. So again, I'm going to look, because I know that if I tried to raise this up and subtract 1, I would have some issues. So we're going to go back to our antiderivatives, and we're looking for something of this form. And it could be going backward to my derivative functions. Because just at a glance, I don't see it right there. Okay. Yeah, so I'm going to look at our derivatives. So the derivative of something gives me something like this, so the antiderivative will go backwards. All right, so I know this is one that's familiar. Derivatives, because I know going backwards. So derivative looks close to this. So minus 1. It is looking really close to this. They just factored out an x. That's what that could be, x squared. You can factor out the square root of 169 and have a constant. So yes, this one looks like arc secant. Okay. If you manipulated some algebra, the square root of x squared is x, so they just have that x pulled out. You can also rewrite this as integral. Let me try to write it so that it looks exactly like that. So what I'm going to do is I'm going to put this x back inside so that this will be square root of x squared. So that x came back inside. Now, the 169, I'm going to factor that out. And that's going to be x squared minus 1. If we do the square root of 169, that's going to give us 13. So I can pull a 13, it's going to be on the bottom. So I can rewrite this as 1 over 13. And then this will be integral of 1 over, this is the square root of x squared times x squared minus 1 with respect to x. So now, me factoring out the 169, I'm sorry, we can't see that. Me factoring out the 169 and then taking the square root, because all of these being multiplied, I can just take the square root of one of them, kind of like that x did. And then that's 13, it's on the bottom, so I'm factoring out a 1 over 13. I put the x back inside so it looks more like the form that we have. So now it looks exactly like this. We just have a constant. So the antiderivative, because the derivative of arc secant is equal to this, so the antiderivative of this is going back to arc secant. So it's going to be a 1/13 arc secant plus c. So this is equal to 1 over 13 ARC SEC of the argument x plus c. So this is one of those given ones. You got to do a little bit of manipulation so you can kind of see. You'll be given different forms, so some different forms may give it to you with the x on the outside. This one puts it on the inside, but those are equivalent forms. I don't think they have another one like that at all. They got the hyperbolic. So we're going with 1 over 13 arc secant of x plus c as our antiderivative for this function. So they're telling you constant multiple, use the definition and rule the fact that this is equal to secant inverse. Maybe I just need to do the absolute value. I didn't put the absolute value right here. That will make a difference.